Full interview answer. How SQL Server stores, reads, writes, and optimizes queries. In SQL Server, everything starts with understanding how data is stored and accessed. Most people think the smallest unit in a database is a row, but actually it's a page, and each page is 8 KOB in size. 8 physically contiguous pages form what's called an extent. All I/O operations, reading or writing, happen at the page level, not at the row level. So when the database reads data, it doesn't fetch individual rows. It loads entire pages into memory first. That means performance isn't about how many rows a table has, but how many pages it occupies. If a table has few records but they're spread across hundreds of pages, it can still perform poorly because the system has to read many pages. So in performance tuning, our mindset should be reduce the number of pages the database needs to read. Cache and the read-write mechanism. SQL Server doesn't cache individual rows. It caches pages in memory. When reading data, the process is 1. Find which pages contain the data. 2. Load those pages into memory, the buffer cache. 3. Return results from memory. When writing, it modifies the data in memory first, and later writes the updated pages back to disk. Also, SQL Server doesn't cache query results like order by, but databases such as Oracle can do that. It's called a result cache. If the dataset is too large to fit in memory, SQL Server has to perform physical reads from disk, which are much slower. Execution plan and cost. Every query in SQL Server is executed based on an execution plan, a roadmap showing how the engine retrieves data. There are many ways to access data, such as table scan or index scan, and the database chooses one based on the cost of each plan. The optimizer estimates the cost using factors like how many pages need to be accessed, and whether those pages are already cached in memory or must be read from disk. It always picks the plan with the lowest estimated cost. This is important because as developers, we often think fewer loops equals faster code. But for a database, it's not about loops. It's about cost. For example, adding a where clause doesn't automatically make a query faster. It only helps if that condition changes the execution plan to one with a lower cost. Index behavior and performance. Indexes are special data structures that speed up data access. They work like a book index. Instead of scanning the whole table, SQL Server can use the index to quickly locate the data page containing the row. However, an index scan can sometimes be slower than a full table scan. For instance, if you index a low selectivity column like gender, which only has 2 values, SQL Server has to look up the index pages first and then go to the actual data pages. That extra jump can be more expensive than scanning the entire table. In that case, the optimizer will choose a full table scan instead. Indexes are most effective when the indexed column is selective, few duplicates. The query returns a small subset of rows, and the index matches the filtering pattern of the query. If many rows match the condition, the cost of jumping between index and data pages becomes high, and SQL Server will skip the index and do a full scan. Multi-column indexes and column order. For multi-column indexes, the order of columns matters a lot. For example, an index on A, B, C is not the same as C, B, A. SQL Server can only efficiently use the index if the query filters on the leading column S in the same order as the index definition. There are 2 common types, 1, single column index, and 2, composite index, multiple columns combined. Choosing the right order is key to query optimization. Full table scan considerations. A full table scan doesn't always mean reading the entire table. For example, you can see the code in our conversation history. This query still performs a full table scan, but the cost is low because it stops after finding 10 rows that match. So not all full scans are bad. What matters is the total cost. Summary. So to summarize, SQL Server works at the page level, 8 KB, not at the row level. It caches pages, not records. The execution plan and cost determine performance, not just the query syntax. Indexes help when they reduce the number of pages the database must read, but not in every case. And finally, the order of columns in an index directly affects query performance. Understanding these core principles helps you think like the query optimizer, not just like a developer. And that's the key to writing high-performance SQL. Bạn có muốn tôi làm thêm phiên bản